Viewing slope, we already wrote a bunch of stuff on the board that you remembered from before. So I'm going to skip straight to the notes. Slope, we already said, describes the steepness basically when we're talking about positive versus negative versus no slope versus undefined slope. It's going to describe the steepness of a line. And you already told me that slope can be found, Lena said, by using this formula, y2 minus y1 over x2 minus x1. And that the rise is the difference in the y values, and the run is the difference in the x values. Everybody okay with that part of the notes? Okay, I expect that you can graph 2 points on a graph from Algebra 1. I expect that you can either use the formula to plug in those coordinates, or that you can count the rise and count the run if it's on a graph. Anybody not able to do those two things? Okay, I would also remind you, if you are going down, what does that do to your number? Makes it negative. If you go to the left, what does that do to your number? Negative. And if you have a negative over a negative, that makes it a positive. All slopes need to be completely reduced, but left as improper fractions. It is not helpful to write your slope as 1 and 1/2, because then if you actually want to graph that line, 1 and 1/2 is not what you need. What you need is 3 over 2, so that you know to rise 3, run 2. Okay? So always reduce your slopes. Don't leave them as 6/4, but leave them as improper fractions when you write your equations. Are we good with that? Okay. So this first part of the first example asks you to find the slope. The lines are already graphed, so you can just look at those lines and calculate slope. The only one it wants you to find is AB, but we're going to talk about the other ones as well. So when you look at line AB, what kind of line is it? Horizontal, so what should be its slope? 0. And again, if you get confused, just ask yourself, if you're thinking about slope, how far am I rising? None. How far am I running from A to B? 5, and 0 divided by 5 is 0. And so that helps you remember, is it going to be 0 or is it going to be undefined? Okay, what about line AD, even though they didn't ask us for it? What's its slope going to be? Undefined, because it's vertical. So the slope will be undefined. And then let's go ahead and calculate one of the diagonal lines. Let's do AC. First of all, just looking at the line, what do we automatically know? What kind of slope should our answer be? Negative. So make sure that your answer matches what your line looks like. It's going down from left to right. So what is my rise from A to C? Okay, it's -5. We're going down 5. Does everybody see that? And then what's the run from A to C? -6. Okay, since we went down, we've already went down, so now we're going to the right, so that's going to be a positive direction. 1, 2, 3, 4, 5, 6. So my answer would be -5, 6. Any questions on calculating slope? Okay, so sometimes you might want to have a graph if they tell you to graph it, but most of the time if they don't tell you to graph it, it's more convenient to use the actual formula. We already said this, so I'm going to move on. So here is one, this next example, where there's not a picture. You could get a piece of graph paper and graph these 2 points and then count rise and count run. But sometimes those points are not going to be pretty points. They're going to be big, like -5,232. Who wants to graph that point? Then that makes it hard. You've got to scale your graph all down. So I would just use my slope formula. So this is one where it's probably easier to do that. So slope, Lena reminded us, was y2 minus y1 over x2 minus x1. And once again, my board's not going to ride on this side, so I'm going to come over here. I don't know what's wrong with that one section. I need to call about that. Okay, so does it matter which coordinate I start with? Not at all. Just be consistent. So what do you want to plug in for y2? Okay, I heard -1 originally, so I'm going to go with -1. So if this is y2, what does this have to be? X2. That makes this one what? y1 and this x1. So it's always x comma y. So we're going to do -1. Don't forget the minus in the formula. So -1 minus 1 over, where do we have to start? 2 minus in the formula 3. What's -1 minus 1? And 2 minus 3. And a negative divided by a negative is a, so this is just positive 2. And you can leave it as a whole number or you can write it as 2 over 1. Some teachers may count off if you leave it as 2 over 1, but it's a fraction that tells you your rise over your run, so that's fine with me either way. Questions on calculating slope? We already talked about this, positive, negative, 0, undefined. That is in your notes. The one thing we didn't mention about slope is related to your application problems, and we're going to look at one in just a second. But slope is, the whole reason you find it is not just so that in math class you can graph these lines. In real life, when you have roads, for example, roads are not always perfectly horizontal. They have hills, they're going up and down, and so they have a slope or a steepness. And so sometimes you'll be talking about slope in reference to an actual road. Sometimes you'll talk about slope as a rate of change. And so when we're talking about a rate of change, we're talking about a slope. And in this example that we're going to look at, we're going to talk about it in terms of miles per hour as our rate of change. So when you're driving down the road and you're going 65 miles per hour, that's a rate of change, which could be translated into a line that relates your distance traveled versus time, and that slope represents your speed, okay, which is your rate of change. So for example, read this problem. It asks us to do two things, right? Graph the line and then find and interpret the slope. The line is graphed for you, but I want to point out some picky things that I will have if your homework actually wants you to graph the line. So I'm going to show you the picture that you have on your paper. When you go to graph your lines for homework, first of all, you have to use graph paper. Don't draw your own graphs. Make sure you leave today with graph paper in your binder. When you draw your graph, instead of having your x-axis and your y-axis in the middle of your paper like most of your graphs are going to have, if you're dealing with distance and time, will any of your values be negative? No. So you may want to shift your origin from the middle of your graph down here to the corner just to give you more room on your graph to spread it out, and only look at that as your whole graph is the first quadrant. Does that make sense? So that this is 0, 0. Second thing is I want you to label your graph with what your application problem is talking about. So what should we label our x-axis with if we're talking about distance and time? Which one's going on the x-axis? Time, because x is always which variable? Say it again. Independent. So you may want to add that to your review sheet. When you're talking about x, it is your independent variable. It occurs no matter what. And when you're talking about y, that is your dependent variable. So the distance that you travel is going to depend on how much time you've been driving, right? So I expect you to label your axes. So the x-axis is time, and this time is measured in what? Hours. So you'll label time, hours. And then the y-axis is going to be your what? Distance, and what's it measured in? Miles. So you're going to label both axes if it's an application problem. Then it tells you to graph the line that represents Justin's distance from home at a given time. So how did they get these coordinates? Say it again, Emily. Okay, so they said at 4 o'clock he's 260 miles from home. So they put the 4 as the x value and the 260 as the y, and then the same thing for 7 and 455. Everybody okay with that? Okay, so then we graph those 2 points. Now, when you're graphing, I expect you to label your axes increments, your scale, if you are going by something other than ones. In this case, to get all the way to 455, we're not going to be able to go by ones. Pick something that does not make your graph super small, that pretty much fills your graph, but then also gets you to your point. So what would be a good increment on maybe a normal piece of graph paper? Maybe 50s. Might be able to go by hundreds. Might be too small because then that's going to shove it way down. You only have to get to 455, and I don't want all of your graph just down here at the very bottom of your graph. So 50s might be good, or 25 might be good. You probably can't go by fives if you've got to get all the way to 455, but you could try and see. So spread it out. I expect it to take up most of your graph, okay? So think about what's a good increment to go by to get to your total amount. Graph your points, and then draw your line. Why isn't there an arrow going this direction? Because your distance or your time are not going to be negative. So really this graph turns out to be a ray, not a line. Any questions about how to graph that? Okay, because I will be pretty picky when we're looking at that part. Okay, it wants us to find the slope. Is this a good problem for us to count rise and count run? No. So let's use our slope formula. What's going to go on the top? Okay, so specifically for these numbers, what would I type in? Okay, Liam said 260 minus 455. What's going to go on the bottom, Liam? All right. All right, we can work with negatives. What is 260 minus 455? Negative 195. What's going to be on the bottom? And what is negative divided by negative? Positive. And how many times does 3 go into 195? Perfect. You guys are all amazing. So we get 65 for our slope. It said find it and interpret it. If it says interpret it, I expect you to write me a sentence explaining what does this mean in relationship to this problem. So what does this mean? A sentence. Sentence. Go ahead, Remy. Okay, and who's he? All right, so we would say Justin is driving 65 miles per hour. Or you could even go more specific that Justin is driving from home to his college dorm at a rate of 65 miles per hour. But the bare minimum, make sure you tell me who it is and what it means. Okay? Questions? All right. Last thing that's in 3.5 here we started talking about was parallel and perpendicular lines. This is why we're doing this. We're not just deciding one day, hey, let's just review some algebra. This is fun. Chapter 3, though, was all about parallel lines and perpendicular lines. And so what we're going to be doing today is finding the slopes of parallel lines and the slopes of perpendicular lines, writing equations of parallel lines and perpendicular lines. So connecting our algebra to our geometry. We are not doing any more proofs in this chapter. I mean, this is all just algebra related. So parallel lines, you already told me, have the same slope. And we would know then if vertical lines have undefined slopes, the vertical lines are also going to be parallel to each other, right? So even though their slopes are undefined, they still are parallel to each other. You told me that perpendicular lines have opposite reciprocal slopes. That's on the next slide in your notes. That perpendicular lines will have opposite reciprocal slopes. But I'm going to go back to the previous slide here for a second because that's not how they wrote it. So I'm going to go back here. The example that we had on the board was 3/2 and -2/3, right? What is 3/2 times -2/3? Okay, -6/6, which reduces to -1. Every single time, because perpendicular lines have opposite reciprocal slopes, meaning change their sign and flip their slope, every single time if you multiply them, which is what product means, the product of their slopes will always be -1. every time. And that's the way this book represents perpendicular lines. They say that their slopes have a product of -1. But what you probably learned before, if you talked about it, was that they have opposite reciprocal slopes. And it doesn't matter to me which way you think about it. Any questions? Okay, look at, I think we have one more example, is that correct? Okay, so one more example in this section. It says graph each pair of lines, use their slopes to determine whether they are parallel, perpendicular, or neither. First of all, I want to remind you for time purposes today, I have given you the graphs. But on your homework, you are going to have to graph lines. So I expect that you can look at this and say, okay, line UV would be made by point U and point V, and that you can graph those 2 points and draw a line through them. Am I correct that you can do that? And lines have what on the ends of them? Arrows. So make sure that you put arrows on the ends of your lines so you don't miss points, because it doesn't say graph each pair of segments. Then it says graph XY, so you would graph point X, point Y, and connect those two together. Everybody's good with that? Okay, so now what we want to decide is, are these two lines parallel, perpendicular, or neither? By looking at the picture, what can we rule out? Parallel. Okay, be very careful with perpendicular. You cannot just look at the picture and think, oh, yep, they look like they're forming a right angle. You have to make sure that they have opposite reciprocal slopes, because one of them may be 999 over 100, and the next one may be, which would be +1, and the next one may be -1. And it may look like a +1 and a -1 when you look at the graph, but it really isn't when you calculate the slope. So be really careful, okay? So let's calculate those slopes. So what's the slope of UV? And this time we could just count, right? Would you agree? So rise is what? 3, and run is 1. And we went up and right, so that is +3 over 1. And then what's the slope from X to Y? How did you get that? So we're going from X to Y. How do I get from X to Y? Or Y to X, it doesn't matter. It'll be the same slope no matter what. So I'm going to go down 2 and right 6. Everybody agree? So that's -2 over 6, or you could have went up to left 6. Either way, you would have one of those numbers negative. What does that reduce to? Okay, make sure you reduce them to check them. So what kind of lines are these? Perpendicular. They're perpendicular because they have the opposite reciprocal slope. Be very careful. They will try to trick you, and they will do this. Are these two lines perpendicular? Why not? Okay, they're both positive. They have to be opposites. So you would say that these two lines are neither. Any questions on 3.5? Would you agree it was pretty much review? All right, 3.6. Before I pass it out, I'm going to see what you know. So go back to your taking notes for review. Okay. So ye started us out, I think, with y equals mx plus b. Was that ye, or was that somebody else? Okay. So we've already talked about that one type of line is y equals mx plus b, and that's the slope-intercept form, and that the y-intercept is the b, and the slope is the m. Everybody's good with that? Does anybody know a different type of equation of a line besides slope-intercept? Molly? Okay, that would not be an equation of a line. That's an equation of a parabola, which is a quadratic. Same thing, just flipped over. Different equation. Has anybody heard of point slope? Okay, raise your hand if you have heard of point slope. Okay, because typically my students come to me from Algebra 1 and they've either barely heard of point slope or they haven't heard of it much or they have just forgotten it completely. Some teachers don't spend much time focusing on point slope, but if you ask most math teachers, point slope at the high school level, point slope is probably the one that's the most useful. When you get to calculus, you're going to be using point slope more than slope intercept. Why is slope intercept not going to be very useful? Okay, because what this y-intercept or slope-intercept form gives you is the y-intercept. And that means if you want to graph this line, your y-intercept has to be something easy to graph. If it's not, this is not very useful. So if you end up with a y-intercept that's like negative 232, you have to scale your graph down to negative 232. That's not as useful as maybe having a different point on your line other than your y-intercept. So point slope is useful because it gives you a point and the slope. And it can be any point. It doesn't have to be the y-intercept. And so then to graph it, you can just graph that point and use your slope to get another point. And so it's more useful because then you can deal with any point and it doesn't have to just be your y-intercept. So point slope formula is y. Does anybody know? No equals yet. Minus y1. Close, we're missing something first. M parentheses. There we go. So remember that the great thing about point slope form is it gives you the slope, which is still m, but then it gives you a point. And the part that most students mess up with on the test in chapter 3 when it comes to point slope is they aren't careful when they pick out their point. Notice the formula has minuses. So when I pick out my point, be very careful. My point is going to be at x1, y1. So when you take it out of the equation, if this is a minus, my x is actually going to be a positive number. And if this is a positive y1, my x is actually going to be a negative because the formula has a minus in it. And the other thing students mess up is they put this first number in the first spot and the second number in the second spot. But be careful, it's always x comma y, so you have to pull from here first and then from here. Okay? So be really careful. All right, so point slope form, we're going to talk about that. Think about x-intercept and y-intercept with me here for a minute. I'm going to go back over here to these horizontal lines, vertical lines, positive, negative. We've got these two equations of a line. But horizontal lines are special and vertical lines are special. They don't fit the mold of y equals mx plus b or y minus y1 equals m times x minus x1. What's the equation of a horizontal line always going to be? That's its slope. What's the equation? That's its slope. Okay, so Tyson said y equals 0x plus b. So if it's 0x, what does that mean about 0 times x? 0. So it's just going to be y equals b. So this is your equation of a horizontal line, y equals b. And what does b stand for again? The y-intercept. Okay, think about a vertical line now. What's the equation of a vertical line going to be? Okay, hold on just a second. Y equals x is an equation of a line that has a slope of what? What number's in front of here? 1. So that means it's going to rise 1, run 1, so it's going to be a diagonal line. So what's the equation for a vertical line? And defined as its slope. What's the equation of the line? Doesn't have a y equals for vertical lines. X equals what? Only if your vertical line crosses through the y-axis, because then the x value is 0. Each line has a specific equation. What is the equation of that line going to be? X equals what? Say it again. The x-intercept. So this equation is going to be x equals, and I'm going to call A our x-intercept. X-intercept. Sorry, I didn't hear it if somebody said something. So y equals b will be your horizontal lines, x equals a will be your vertical lines, and b is always your y-intercept, and x is always your x-intercept. Okay? When you think about a graph, what is the coordinate for an x-intercept? Something 0. So what did we just call our x-intercept? A. So this would be A, 0. What is the coordinate for a y-intercept? 0b. So keep that in mind. You can write your x-intercepts and your y-intercepts as ordered pairs. Let's see what else. All right, let's go back to our parallel and perpendicular lines. So parallel lines we had said have the same slope. So if they have the same slope, their equations are going to look similar, right? They're going to have the same slope. Will they have the same y-intercept? No, because if they did, that would mean that the two lines would actually do what? They would intersect. If they had they would actually overlap. They would be the same exact line. If they had the same slope or the same y-intercept, if they had both of those, they would be the same line. Do you know what we call it when two lines have the same slope and the same y-intercept? We call them coinciding. Add this to your notes. So we're going to call those a separate kind of lines. We've got parallel, perpendicular, or coinciding. Coinciding lines are going to have the same slope and the same y-intercept. So if they give you two separate equations and they turn out to have the same slope and the same y-intercept, you say that the lines are coincident lines or coinciding lines. Coincident or coinciding. Okay, so let's go back to parallel lines then. Parallel lines are going to have the same slope, but what about their y-intercepts? Different. So they're going to have different y-intercepts. Okay, what about perpendicular lines again? They have opposite reciprocal slopes. Will they have the same y-intercept? Molly? Very good. So if they could have the same y-intercept, for example, on this picture, if the axis was so that they were crossing on the y-axis, then they would. But do they have to have the same y-intercept? No. Okay, so they have opposite reciprocal slopes, and y-intercepts just depend on the equations. Okay, so that's pretty much 3-6. Let's look at some examples. I'm going to pass out the notes. There's some harder ones on here that we'll talk about, and some things not on here that we'll talk about. They have opposite reciprocal slopes, but they can or cannot have the same y-intercept. It just depends on the problem. If they cross at the y-intercept, then they have the same y-intercept. But if they don't cross at the same y-intercept, then they'll just have different y-intercepts. So they can cross anywhere. Does that make sense? Okay, so let's try some problems together. So 3-6. Again, I'm going to go pretty fast through the parts we've already talked about. So this slide we've already really discussed. Here's your point slope formula. Here's your slope intercept formula. The equation of a vertical line is x equals a. The equation of a horizontal line is y equals b. So those things are listed in your notes. Are we all good with that? Okay. We talked about what a y-intercept looks like and what an x-intercept looks like as an ordered pair. So that's here in your notes. And now we're going to talk about how to write equations of lines. Be very careful on the test and on the homework. You will get 0 credit if you use the wrong form, if they tell you specifically which form to use, because that's what I'm testing. So be really careful. It says write the equation of each line in the given form. What form are we supposed to use here? Point slope. So the first thing I would do is start with my point slope formula. What's point slope? Okay, I'm going to move over to this other side. I keep forgetting to not write on the left. So that's my formula. I'm going to plug in my information. What does it tell me? Slope of 6, so where does that go? M. And then it gives me a 0.3 negative 4 that it passes through. Where's the 3 going to go? X1. Be very careful. The y and the x without a subscript are your variables that constantly change, that create all the points on your line. This x1, y1 is a specific point on your line. So 3 is going to go in for x1. So we're going to have x minus 3. And negative 4 is going to go in for y1. So what are we going to have on the front here? Y plus 4. Because it's y minus a negative, which becomes a positive. Super simple. Circle it. That's all you have to do. Questions, though, if it wasn't super simple and you're not sure what I just did? Are you good, Yee? Yes, ma'am. No, because they don't want it in slope-intercept form. They don't want you to rearrange the equation. They want you to leave it in this form so that it's easy to identify the slope and the point. Okay? Good question. All right, the next one. I don't know why this is on here. I didn't give it to you, did I? Okay. Okay, good. Shouldn't be on there. All right, so it says write the equation of each line in the given form. The line that passes through negative 1, 0 and 1, 2 in slope-intercept form. So what is slope-intercept form? What is it again? Slope-intercept. Y equals mx plus b. Be super careful that you are using the right form. I'm telling you, that's the part where you'll be so frustrated if you use the wrong form and got this wonderful answer that I'm checking to see, do you know the difference between slope-intercept and point slope? Okay, so what do we need to know to write this equation? Slope and the y-intercept. An equation of a line always has a y and an x, but it has a number for slope and a number for y-intercept. So how are we going to find our slope? Slope formula, the change in y over the change in x, rise over run, we're going to plug it into our formula. So the first thing we need to do is calculate the slope. So let's do that. What's going to go on the top? Careful. 2 minus 0. So it should be y minus y. 2 minus 0. What's going to go on the bottom? So it'll end up being 1 plus 1 because it's going to be 1 minus a negative, right? So what does that give me when I simplify? 2 over 2, which is 1. I'm going to write it here so I'm not in the way of my equation. All right. So now plug that in. We have a slope of 1. We have a y. We have x. How do we find b? Say it again. If I plug in 0 for x, I'll still have 2 variables, a y and a b. Still, I would have 2 variables. I don't need to plug 0 in for anything. Okay? This is my equation. I need to calculate b. Lucas? Say it again. Plug in one of the y's for b. B is my y. hold on guys, B is my y-intercept. It's not just any y value. It is a specific number where it crosses the y-axis. So 2 is not where it's going to cross the y-axis if it's going through 1, 2. And 0 is not where it's going to cross the y-axis if it's going through negative 1, 0. So I don't know my y-intercept. I need to find it. Okay? Okay. Hannah? Exactly. I want to make sure you guys understand what you're doing. This is an equation that calculates the graph of a line. The y and the x are all of the different points on that line. We need to find the specific point where it crosses the y-axis. But every one of these coordinates stand for x and y at different intervals along your line. So you can pick one of these 2 points to plug in for x and y, and it will calculate the value for b. Does it matter which point we use? No. So what do you want to use? Okay, I heard the second. So 1, 2. So that means what's going to go in for the variable y? 2 equals 1 times what's going in for x? 1 plus b. What's 1 times 1? 1. What do we do to solve for b? Minus 1. So what is b? 1. Okay, is that my answer? No, we're trying to write an equation of a line. Our final answer should have a y and an x in it, but it should have a number for m and a number for b. So what was the number for our slope? 1. What was the number for our y-intercept? 1. So plus 1. Okay, so to write an equation of a line, you have to find your slope. Yes, you sure can. Sorry. And I think that Mrs. Sigurd actually counts off if you put a 1 in front of your x. Thank you. So just making sure. So completely simplified, this is the same as y equals x plus 1. Are we good with that? Okay. Any questions? All right. You're going to have to do a lot of problems like this. It's super important that you understand on the test. This is the section where most students, if they know their algebra, do amazing. If they don't know their algebra, they struggle. Okay, so let's look at the next one. Write the equation of each line in the given form. The line with the x-intercept of 3 and y-intercept of negative 5 in point slope form. What is my equation I'm going to start with? Okay. Thank you. Y minus y1 equals, good, so point slope gives me a point and the slope. All right, so next, what am I going to do to find my answer here? Okay, what am I going to plug in? Okay, those are my intercepts. So those are my x-intercepts and my y-intercepts. Molly? Very good. The biggest mistake I see for this example is students will write this down on their paper. 3, negative 5 is a point on the graph at positive 3, negative 5. Is that an x-intercept or a y-intercept? No. An x-intercept is a point. It has its own specific coordinates. What are its coordinates? 3, 0. A y-intercept has its own specific coordinates. What is it? 0, negative 5. So be very careful you don't try to put those together and make a different point. That is wrong. So now we have these 2 points, and we need to write an equation in point slope form. Point slope form has a point in it, x1, y1. Does it matter which point we use? Nope. And then it has a slope. How are we going to find slope? Rise over run, slope formula. So first thing I would do is calculate my slope. So what's going to go on the top? I heard really quietly negative 5 minus 0. So if we go that way, what's going to be on the bottom? 0 minus 3. What is negative 5 minus 0? Negative 5. What is 0 minus negative, or 0 minus 3? And what's a negative divided by a negative? Positive. Ooh. 5/3. So I'm going to plug that in here. 5/3 right and go here on the left. What's going to go in for x1, y1? Either point. So there's two different answers you could write down and get credit. Pick one. Don't plug in 3, -5. So either you're going to write y minus, and I'm going to use my y-intercept here. So this would become y minus what? -5. So it becomes a plus 5. And then in parentheses, I'll have x minus 0. And you will leave it like that. Do not simplify it because it wants it in point slope form. Okay, so don't get rid of the -0 part. Leave it there. It helps you see your equation. Or you could plug in the other point. If you plug in the other point, you're going to have y minus what? 0 equals 5/3 times x minus 3. And both of them are acceptable answers. You don't need to write them both. Questions? Going on. You guys go ahead and do this one. We'll check it. While you're doing that, I'm going to pass out some graph paper for the rest of it. When you get the equation, go ahead and go to the next problem and graph the line on this piece of graph paper. Not this one, but the next example in your notes. So one more time, when you finish writing this equation, do the next example, graph that line on graph paper. And then we'll check on both in just a second. I got you. You got one. You do have one. Or you need one. Okay. You guys need a ruler. There's one for both of you. Over in just a second. Okay, I'm going to ask you, once you get that graphed, we're going to see how much you knew how to do and what I need to review with you. So first of all, go back to this one. Write the equation of a line in the given form. Slope-intercept form, which should have been y equals, put your rulers down, y equals mx plus b. It is a slope of 0. So that would be 0x, and it's passing through the point 4, 6. So you could start with this equation and plug in 6 for y and 4 for x and solve for b, which is what we just did on the previous problems where we were trying to write the equation. What is 0 times 4? 0. So this gives me 6 equals b. Then I go back and I write my equation. Y equals 0x plus 6. And you could leave it like that because it said in slope-intercept form, but what does that simplify to? Y equals 6. And did I really need to go through all that work to get that equation? We said earlier today that horizontal lines are always going to be y equals a number, and horizontal lines have a 0 slope. If I have a line passing through the point 4, 6, and it's horizontal, then that means the equation is just y equals the y coordinate, 6. Those should be the easy ones on the test, and they're going to be the ones that you're going to miss if you don't pay attention right now. Lena. You could, as long as it was still in slope-intercept form by the end, yes. What if, I'm going to ask you to add here real quick, what if it had said, write the equation of the line in the given form if the slope was undefined? So make a little note over to the side, and it passed through 4, 6. Without showing any work, what should be the equation of that line? X equals, and what is the x value that it's going to pass through? 4. So it should be a super quick answer. Oops, where you don't have to show any work. Okay? Questions there? Okay, I'm going to do a little side note again, and I want you to add these examples to your notes before we move on, because these are going to be on your test, and I don't think they do a good job in the notes here. I didn't put examples like this. So, add this somewhere in your notes. Write an equation of a line parallel to x equals 3 that passes, bless you, through 2, 4. Write an equation of a line parallel to x equals 3 that passes through 2, 4. And you shouldn't have any work to show. You should just be able to write the answer. What would it be, Hannah? Okay, if it's parallel, it should be the same kind of line, right? What kind of line is this x equals 3? No, 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 no. Diagonals have a y and an x. Remember ye? Vertical lines are just x equals a number. Okay, so what kind of line is x equals 3? Vertical. Say it again. This is a problem I gave you. This is extra problem. Write it down in your notes. Okay, that's what I said to start with. So make sure that you are writing this down somewhere separate on your notes, because this is going to be on your test but is not in the notes today. Okay, so write an equation of a line parallel to x equals 3. What is this kind of line? Vertical. So that means the equation I write, if it's going to be parallel, has to be x equals, because it has to be vertical. So it has to be x equals, and if it goes through this point, what is the x going to equal? 2. Okay, same exact problem now. Add this to your notes. It's not in your notes right now. Same exact problem, except this time I want you to write an equation perpendicular to x equals 3 and goes through 2, 4. Perpendicular to x equals 3, but goes through 2, 4. So what kind of line is x equals 3? Vertical. So what kind of line would the line have to be if it's going to be perpendicular to a vertical? Horizontal. And horizontal lines always start with what? Y equals. And what number is the y going to have to be if it goes through 2, 4? What is y going to have to equal if it goes through the point 2, 4? No negative. Y is going to equal 4. We're not finding slope here. We're writing an equation of a line. Different than finding slope. The slope of a horizontal line is always 0. The slope of a vertical line is always undefined. So we're not doing opposite reciprocal slope here. We are just writing an equation. If this is vertical, our equation has to be horizontal. Horizontal lines are y equals, and it's just a number. That number is going to be the number that it passes through. If it goes through the point 2, 4, then that number has to be 4. Does that make sense? Questions if it doesn't, because I promise you this will be on your test. And it should be easy, but it's not easy if you don't understand. Really? We're good? Okay. That was just a side note. Make sure you have those in your notes. All right, so graph each line. So this one said graph it. I gave you graph paper. I gave you a ruler. What form is this in? Point slope. So let's start with, what is our slope? -2. What is a point on our line? Very good, Remy. Be very careful, everybody. Remember, your equation is y minus y1 equals m times x minus x1. So when you pick out your point, the formula had a minus. So what did x1 have to be if this is a positive? Negative. If this is y minus y1, then what is y1? Positive 3. When you pick out your coordinates, you have to change the signs. Are we good? Yes. Okay. So now we're going to graph that. You should have went to your graph. I think they already have it in the notes here, so I'm just going to show it because it's probably prettier than mine. You should have graphed the point, -4, +3. And then you should have used the slope, which we said was -2, which means you're going to go down 2, right 1. Down 2, right 1. You can graph that as many times as you want, or you can only do it once and then use your ruler. Make sure you're putting arrows on the ends of your line. Questions? Make your lines go all the way through your graph as you're getting ready for Algebra 2. Your Algebra 2 teacher is going to want your lines to completely go to the ends of your graph. Am I correct, Lena? So getting you ready for Algebra 2, practice now. Don't just draw a short little line on your paper that looks like this. Go all the way to the ends of your graph. Complete your graph. Questions? Okay, again, this is one of the very missed questions on the test too, because students will forget to change the signs when they pick out their point. All right. I'm going to ignore that for right now. We already talked about this. Parallel lines have the same slope. Coinciding lines have the same slope and the same y-intercept. And if they're not parallel and they're not coinciding, then they might be perpendicular or they may just be intersecting. So sometimes on the homework it's going to say, tell me whether they're parallel, coinciding, or intersecting. And so all you're checking to look and see is, do they have the same slope but a different y-intercept, or the same slope and the same y-intercept? And if they don't have either one of those, then they're intersecting. If they have different slopes, they might be opposite reciprocals. Then that would make them perpendicular. If they are not opposite reciprocals, then they're just intersecting. Any questions there? Okay, look at the next two examples. Go ahead, I think there's 2. Is that right? Go ahead, maybe there's 3. Nope, just 2. Do the next 2 with your partner and decide if you think they're parallel, coinciding, or intersecting. Put it on your paper. Be careful that you read your directions. It did not ask you about being perpendicular. It's parallel, intersecting, or coinciding. Write it on your paper and then go on to the next one. What are you going to have to do on the second equation before you can answer that? Okay, you've got to get y by itself. It's got to be in slope-intercept form before you can pick out your slope. It's not just the number in front of x. Only if it's in y equals mx plus b form is it the number in front of x. So make sure you get it in y equals form and then compare your slopes. Can give you about 30 more seconds. If you're struggling, ask somebody by you. Hands up if you're done with both problems. Okay, if you're not done, that's okay. Look up here. Remember, it's got to be in y equals mx plus b form before you can pick out your slopes. When you compare those two slopes, are they the same? No, which means if they're not the same, then they're not what? They're not coinciding and they are not parallel. Parallel has to have the same slope. Coinciding has to have the same everything. So these are neither those, so it is what? Intersecting. Okay? Is it perpendicular, by the way? No. They do have they have opposite signs, but what's not happening? They're not flipped. They're not reciprocals. Okay? So these are not perpendicular. They're just intersecting. I don't know why I keep doing that. Okay. Next equation. When we look here, this one has a slope of what? But this one is not in slope-intercept form. So first we have to divide every single term by 6. Do not pick and choose. Make sure you do every one of them. So that gives us y equals negative 1/3 x plus what? 2. So now look at them. Do they have the same slope? Do they have the same y-intercept? So that means these are? All right, last example is an application problem. So there is a typo, by the way, right here in the chart. This should say 50 cents per mile. So please add that in your notes. Let's read this together and see if we can show our work and solve this. Erica's trying to decide between two car rental plans. For how many miles will the plans cost the same? This whole lesson has been about writing equations of lines. So more than likely, we're going to need to write equations of a line, okay? So look at our information here. Plan A has an initial fee and a mileage fee. The initial fee is $100. The mileage fee is 35 cents per mile. What do you think this represents in terms of a line? Slope, because it is a rate of change. Slope is always a rate of change. This is 35 cents per mile. So this is our M. What do you think the initial fee represents? The y-intercept. It's where we're starting our value on that y-axis at time 0. This is our initial fee. So this becomes our B, which it's not going to let me write. Does that make sense? At time 0, the initial amount we'll pay is $100. Okay, so let's write an equation for plan A. So plan A would have the equation y equals what? Okay, 0.35x plus 100. Now let's go to plan B. What would our equation be? 0.5x plus 85. Stop me right now if you do not understand where those equations came from. Okay, now read the directions again. For how many miles will the plans cost the same? So what in our equation is going to represent the number of miles? Okay, so if this is 35 cents per mile, then that means we're going to be plugging in for x the number of miles. So x is our number of miles, and that makes y going to calculate the what? Total cost, because this was our initial cost, and this is the cost for all the miles. So that means y is going to represent the total cost. And we're trying to find what? For the cost to be the same. So what's that going to mean about the y values in the two different plans? They'll be the same. So what could we do if we want this to equal the same number as this? Very good, Molly. We could just simply substitute this in for y, which means we're just basically setting the plans equal to each other. Okay, so let's do that. I'm going to do it on the board over here because my whiteboard keeps messing up. So let's solve here. So we have 0.35x plus 100 equals 0.50x plus 85. Be very careful with your decimals. What would I do here to solve? Subtract what? 0.35x or 85. Doesn't matter, right? So I'm going to subtract this 0.35x so I don't end up with a negative. Is that okay? All right. So I have 100 equals, what's 0.5 minus 0.35? 0.15 or 0.15x. And then I'm going to subtract 85. So what is 100 minus 85? 15 equals 0.15x. So what do we do to solve for x? Divide by 0.15. Okay, so we need to find x. So how would I do that? Lucas? Okay. So Lucas is saying he just moved his decimal point 2 places to the right, but if I do that on the bottom, what do I have to do on the top? Do it also. So I could just move this 2 places to the right, and so instead of having 15 over 0.15, what am I going to have? 1500 over 15. And when you're moving it 2 places, what you're really doing is multiplying the top and the bottom by 100. And so that would work. That would make it easier. And so 15 goes into 1500 how many times? 100. And so x is equal to 100 what? Miles. And so make sure you write me a sentence if it is a word problem like this. So for how many miles will the plans cost the same? The plans will cost the same. You sure could. You sure could write it that way. That would be awesome. The plans will cost the same at 100 miles. What will the plans cost at 100 miles? How do I get that, Malachi? Plug in 100. So I could go to either plan, right? Because they're supposed to be the same. So 100 times 0.5 is, it's 50, and 50 plus 85 is 135. Or 100 times 0.35, 35 plus 100 is 135. So it might ask you, how much do the plans cost? And you would need to plug it back in. You sure should. The plans will cost the same at 100 miles for Miss Erica. The more you can give me about the problem, the more I'm preparing you for Algebra 2. I'm probably going to be a little less picky than where I know you'll be headed, but they're just, again, trying to step it up a little bit more. Not because they're being more evil, they're preparing you for college. That means your college professors are going to be the evil ones. So